Hello and welcome back to the second segment of graphing sine and cosine functions. And today particularly we're going to talk about graphing the cosine function. Now let's look at this very closely. The cosine function has a period 2 pi, just like the sine function does. And we can proceed just like we did before by creating a table which actually lists some of the points of the graph of y is equal to cosine x. 0 less than or equal to x less than or equal to 2 pi. As you look at the table of y is equal to cosine x, with 0 less than or equal to x less than or equal to 2 pi, it starts at the point 0, 1. And as x increases from 0 to pi over 2 to pi, the value of y increases from -1 to 0 to 1. As before, we plot the points from the table 1, and we get one period or cycle of the graph. Now, let's look at the table. And here's our x values here. And when we plug this into cosine x, then we get our values y right here. And this is listed also as well, clearly, nice and neatly, in their precision. And then what we do, we plot these points on the graph, and then we get a nice smooth curve. And as you see, here we have from like 0 to 1 is where it starts, 0.01. And we have an amplitude of what? Remember now, this before you answer this question, remember from the last videotape that we looked at the sine function. Just as well as this one, y is equal to cosine x. That is understood to be a 1 there, right? That's understood to be a 1 there. So that is the amplitude. The amplitude which has the values, all the values between -1 and 1. When we draw the curve from 0, right? From 0 to 2 pi. So understand how the cosine graph, that sort of does a little dip, doesn't it? Right here. So that's because for this particular function of cosine x, the amplitude being 1 is going to start at 0.01, as we see very clearly. Now, just like before, and the cosine function is a little slightly different. We're coming from -infinity to +infinity. As you see, y is equal to cosine x comes from -infinity, which you say -infinity less than x less than +infinity. So basically, this is an inequality notation. Is an interval notation. It'll go from -infinity to +infinity. However, the behavior of the graph, remember, it continues its behavior pattern just like it will, all the way continuing from -infinity to what? +infinity. So, let's go and let's look at some points here. Let's look at some properties. And these properties are very, very important. The properties of the cosine function, y is equal to cosine x. The domain also as well is a set of all real numbers, just like the sine function. And the range consists of real numbers from -1 to 1 inclusive. These are all included. And that the cosine function is what? As you see. Can you answer that question? What is the cosine function? Is it even? Or is it odd? If you notice the previous videos, we did a video segment on even and odd of trigonometric functions. However, I'll just go ahead and tell you, if you missed those videos, the cosine function is an even function because the graph is symmetrical with respect to the y-axis. As you remember, taking college algebra or algebra 2 talked about even and odd functions, right? And so we know that the odd functions are basically symmetrical with respect to the what? Origin. Well, the even functions are symmetrical with respect to the y-axis. Now, the cosine function is also periodic with period 2 pi, and the x-intercepts are from negative infinity to this point here of negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and 5 pi, and so on. And then, of course, the y-intercept is 0. Okay, the maximum value is 1, and it occurs at x is equal to, say, from negative infinity there, right, to negative 2 pi, 0, 2 pi, 4 pi, 6 pi, so forth and so on. And the minimum value is negative 1, and it occurs at x from negative infinity to what? Negative pi, pi, 3 pi, 5 pi, and also so forth and so on. Now let's get into graphing functions of the form of y is equal to a times cosine of what? Omega x. Now, we're going to graph the function using transformation. Now, when you graph y is equal to 2 times cosine 3x. Here's what we got. Let's talk about the cosine function y is equal to cosine x. So basically, it transforms. When we multiply by 2, it stretches what? Vertically, as you know, as you see that, right? This being the what? This being the amplitude of 2, right? And this being the amplitude what? Of 1. You see that vertical stretch. And it's by what? The factor of 2. Because it's being multiplied by 2, so it's going to give you a different look. So, how about if we move on and we talk about when we place x with 3x? This is what we have here. So, it's a horizontal compression type of situation where it's being compressed by the factor of 1/3. Now, let me just break that down and show you what I'm talking about. Well, you know the formula for period is equal to 2 pi over omega. Okay, so let's talk about the horizontal compression for a moment of the factor being 1/3. Now we know that if we replace x with 3x, right? This coefficient value is omega. Now, as the period is equal to 2 pi divided by omega, which equals to 2 pi, and I'm writing it differently, which means the same as this now. We say 2 pi times 1/3, which that's the factor, and that causes this horizontal compression. So with that, when you multiply this, your period is 2 pi over 3, because it's being compressed horizontally, you see. So the period from here to what? To there, 2 pi over 3. And that is your period there for this particular function. If you have any questions, or if you need to stop the video, feel free to stop the video, pause it, take great notes, and of course, if you have any questions in the classroom, we will discuss it. But in the meantime, this completes our segment of graphing, cosine, and sine functions, and we'll continue on another segment and go more in detail with amplitude and period.